Yes, good morning, every one of you. So until the last class, we were seeing this unit 2. So resistance thermometer, radiation temperature measurement, and composition analysis. So we have covered so far this resistance thermometer, radiation temperature measurement, and now we are going to start this part 3, which is composition analysis. So contents here we have seen already. So topics, part 1 topics entirely we have seen. Then part 2 also we have covered radiations. And today we are going to start this part 3 of this unit 2, which is methods for composition analysis of moisture in gases. So first method we are going to see this hygrometer method. So to measure the moisture in the gases, we need a hydrometer or hygrometer, we can call that one. So what is this hygrometer? So this hygrometer is nothing but a one type of medium or instrument to measure the moisture which is present in the surrounding gas or air. So to measure that one. So humidity is nothing but the amount of water vapor which is present um, in that particular gas or in a gas in a air. Okay, that is our humidity. So to measure this humidity, so first of all we need a partial pressure of the water vapor in the gas or a air, and the vapor pressure of the liquid. Then if you have a partial pressure and vapor pressure, we can easily express the relative humidities. So this type of instruments will use, there are two methods to measure moisture using hygrometer. So one is the mechanically operated method. This second one is the electrically operated method. So all these humidity meters will operate on a basic principle that every natural material like a human hair or animal membrane, wood, paper, all these materials will change in their linear dimension whenever they are exposed to the moisture. Okay, they will change their linear dimensions whenever they are exposed to something else, or they will also change the electrical properties. Okay, using the electrical method also we can measure the moisture, and first one is the mechanical method. So in the mechanical method, the change in the linear dimensions will be observed for the all the natural materials like animal membrane, human hair, wood, or this paper. Everything we can use as a medium of measurement for the hygrometer as a construction material. So due to the humidity, several materials such as this human hair or this animal membrane, wood, paper will change their linear dimensions. Both the physical, chemical, and electrical properties also will change. So this properties is used in transducers that are designed and calibrated towards to measure the relative humidity directly. So therefore, the linear dimension change of this particular hair material or some hygroscopic material, so that their linear change in dimension will be calibrated accordingly on a calibrated scale, whose scale will be read in the relative humidity. Okay, will be in the relative humidity. So therefore we can directly measure what is the surrounding moisture which is present around that particular hygrometer. So commonly there will be using of this hair hygrometer, in which hair will be the medium of construction here. So medium of construction here will be the hair. So naturally all the natural materials will have a absorption tendency for the moisture, or they will be called as a hygroscopic materials. So the linear dimensions of every hygroscopic material will change according to the moisture which is present in the surrounding air. So this construction as shown in the figure, you can see the construction here. So usually the hair or a human hair we can consider, the human hair will be used to measure as a humidity sensor, used to measure the humid moisture, which will be called as a sensor here. So the hair will be arranged in a parallel beam, okay, in this type of beam structure. In order to provide a good strength to this particular beam, number of hairs will be arranged in a parallel, and number of hairs will be placed in a parallel, and therefore the mechanical strength of that particular hair material will be increased by arranging the number of hair materials inside that particular sensor. Then the hair is connected to the arm, okay, this arm and spring tension, and also to the link. Okay, therefore depending on this deflection, linear deflection in their dimensions, depending on that one, this will produce some tension in the spring. So that tension will be gauged by the link pointer which is connected through the link, or a pivotal pointer we can say this one. So this pointer will be deflecting from its standard position, and therefore the position of this pointer can be calculated, can be placed on the calibrated scale, whose scale will be in the relative humidity. So usually this type of materials, this type of sensors can be used to measure the relative humidity from 30 to 95%, and only under the temperatures of 0 to 75 degrees centigrade we can use this particular hygrometer or a sensor. So the operating principle here is all the natural materials or hygroscopic materials will change their linear dimensions according to the moisture which is present in the surrounding air due to the absorption. Okay, whenever you are exposing this particular hair sensor, so this hair sensor will be constructed using a hair material which are arranged in a parallel. So due to provide the mechanical strength, the good mechanical strength to that particular hair material, we will be arranging number of hair materials in a parallel way. Then afterwards, this hair materials will be connected to the spring so as to provide some support, and this spring will be connected to the pointer with the help of a link. Therefore, whenever the expansion or contraction of this hair material is there, that deflection, that change in the deflection of this hair material or a hair sensor will be producing some tension in the spring. That tension will be gauged by this pointer which is connected to the link, and this pointer will be rotating onto the calibrated scale whose scale will be in between 30 to 95%. So to do that one, in this chamber there will be circulation of some gas or some air which is having a moisture. Whenever the moisture is there, that will be absorbed by this hair material and it will produce a deflection accordingly. So this is also one type of other type of construction. In this also, hair will be used as in a parallel way. It will be used and it will be connected to the pointer using the arm and link. And therefore, to support this deflection, there will be a tension spring will be there to counterbalance that particular tension. So this type of thermometers were very much popular. They will be used. They will be used in many industries, but they are not much accurate. Why? Because all these are the natural materials. Here, if you use a hair material, we can call this as a hair hygrometer. If you use a wood material, you can call this as a wood hygrometer. If you use a paper material, you can call as a paper hygrometer. So the applications will be the same, 0 to 75, and this relative humidity is 30 to 95%. We can easily use, but they are very much limited in use. Why? Because they are very slow in response. All these are the natural materials. So natural materials, whenever they will contract or they will expand or contract, that will we cannot control that one. So it has to go on naturally. Due to this natural process, they will be slow in response and they are not much accurate. And drift and calibration drift will be very high. Why? Because the aging effect will be there on the natural materials. Obviously, whenever you use the same thing for the repeated number of times, due to its naturality, it will lose its naturality. Due to the loss of its naturality, it will be resulting in your drift, inaccurate results it will give after a much period of time, after using many times this same hygrometers. So this is about the hygrometer, mechanically operated hygrometer. I hope it is clear. Mechanically operated hygrometer.
Yes, sir.
So next one will be the electrical hygrometer. So there are two methods to measure the hygrometer. Using hygrometer, one is the mechanically operated. Then second one is electrically operated. Electrically operated. So mechanically operated, we have seen the examples are hair hygrometer, wood hygrometer, or paper hygrometer, animal membrane hygrometer. Okay, whatever the natural materials are there, which can have a tendency to change their linear dimension whenever they are exposed to the moisture, we can use that materials as the mechanically operated hygrometer. Then now we will see the electrical operated hygrometer. All the materials, whatever the materials are there, will have a natural tendency to absorb the moisture. So that will change their electrical properties also, not only the linear dimensions as we have seen in the mechanically operated, but also their electrical properties will do change there. So electrical hygrometers is usually composed of some polystyrene cylinder will be there like this. Okay, polystyrene cylinder will be there, onto which some precious metal wire like a copper or something like that. It will be double wound. Okay, it will be winded like this. Like our fans will contain some winding, no? So like this, it will be winded. So the wires are very much precision spaced. They are very much precision spaced. At the end of this particular connection will be provided in the base. So like this, some connections, electrical connections will be provided in the base of that particular polystyrene cylinder. So this is polystyrene cylinder. This is some precious metal wire. So usually this cylinder material will be coated with a thin film of your polyvinyl acetate. A thin film of some polyvinyl acetate will be provided. Polyvinyl acetate. So PVA means polyvinyl acetate plus with a small fraction of lithium chloride, which is very much hygroscopic material. PVA plus lithium chloride, which is a hygroscopic material. After coating this one as a thin film there, since the lithium chloride is a hygroscopic material, this is hygroscopic. Okay, this will easily will gain the moisture from the surrounding it. Whenever this is exposed to some moisture like this, if this is a moisture like this, so this lithium chloride will easily absorb the moisture which is present inside that one. Therefore, its electrical conductivity will be changed. The lowering or the lowering or the gain of this electrical gain of this moisture will change their electrical properties or electrical conductivity of that particular wire material will be changed. So this electrical conductivity, whenever it is changing, its electrical resistance will also change. That change in electrical resistance can be calibrated using some bridge circuit. Okay, Wheatstone bridge circuit or Calendria bridge circuit which will be connected here to the terminals. Okay, we know the operation of the Calendria bridge circuit or the Wheatstone bridge circuit. So therefore, the first is electrical hygrometer will usually constructed using some polystyrene cylinder onto which there will be a precious metal wire like a copper or something like that will be winded. A double winding will be provided and therefore a precision winding will be there in between them. And after that one, the top surface of this winding will be coated with some polyvinyl acetate plus a small fraction of lithium chloride film. So this lithium chloride is very much hygroscopic since it will absorb the maximum amount of moisture which is present in the surrounding atmosphere. Therefore, an electrical resistance of the wire will be changed due to the absorption of the moisture. That electrical resistance will be calibrated using some bridge circuit, and we can use a psychrometric chart or the humidity chart can be used to calculate the humidity. So this resistance will be used to calculate the humidity, relative humidity, and humidity can be calculated using the psychrometric chart. So psychrometric chart or humidity chart, both are same. Metric or humidity chart. So humidity chart will be there. So that humidity chart we can easily use. For example, just for the example I'm showing here, you need not to remember about the humidity chart here, just for your awareness. So humidity chart will be there in which the abscissa will be temperature like degree Fahrenheit. Then this ordinate, so y-axis, so abscissa or x-axis we can call this one. This is ordinate or y-axis we can call. On the y-axis there will be the humidity. And here there will be some humid heat. Humid heat we will call that one. Then here the volume will be there. So like this all the four axes will be there for this particular graph, and therefore the humidity at 0% humidity means there is no moisture in that one. Then there will be some 10% humidity, 20% humidity, 30%, 40%, 50% until 100% it will be there. Then after that one, there will be a saturated volume versus temperature. Okay, then there will be an the specific volume versus temperature will also be there. One scope. Then CS versus humidity. So this humid heat versus humidity. Humid heat versus humidity will also be there, and there will be some adiabatic cooling lines like this will be there. Okay, all this will be there depending on the whatever the criteria which we adopt here. Using this psychrometric chart or humidity chart, we can easily find out what is the humidity around surrounding that particular hygrometer. So this has a many advantages. Since this is an electrically operated hygrometer, its response will be fast compared to the mechanically operated hygrometer, and also its accuracy is very high. plus or minus 1% nearly we can observe its accuracy. And the moisture equilibrium between the salt film, this lithium chloride plus this PVA film which is there on the element, and the surrounding gas will be reached very quickly. The equilibrium between the surrounding gas moisture and the moisture which is present in the particular salt element, lithium chloride element, will be reached very quickly. Because of this, the accuracy will be very high. So that is what the electrical hygrometer. I hope this is clear.
Yes, sir. Clear, sir.
Yeah. So this one. So I have given in the PPT here what is the principle. For the explanation and everything, description, working principle, everything, you can refer the notes. Only the diagram I have shown here. So this is mechanically operated and electrically operated. Whatever I have drawn that one. So using visualization, you can draw. In the textbook, this also not there. From internet, I have collected these two hair hygrometers. Okay, for electrical, there is no diagram, so you can draw by your own. So next one is the pH concentration measurement. So since you are measuring the pH in the chemistry lab itself, I request someone from among you to present this topic. So how to measure the pH using this standard electrode or the measuring electrode. This will be very easy. So go through this one first and then let me know tomorrow who is going to present this one. Tomorrow, I will take as a assignment 2. So those who are presenting, so they will get a full marks in the assignment 2. Okay, please let me know afterwards. So who is going to present this one? This will be very simple method. So next one will be the hydrogen sulfide detection system. So hydrogen sulfide detection system. So this will be coming under the class of special methods. Yes.
Sir, I'll take up the topic, sir.
Yes, Jeevan, expected, as expected. Thank you. Yes. Okay, hydrogen sulfide detection systems will be there. So first we will classify what are the various special system or spectral systems which are there to measure, which are there to analyze the gases. So first is there are some special methods will be there. Special method of analysis. So among them, the first one is heat of combustion method. Heat of combustion method. So usually this heat of combustion method will be used to estimate the presence of CO2 and hydrogen in the surrounding gases. Then second method will be there, the chemical methods we can use. So this can be used, this method can be used to estimate hydrogen sulfide, H2S, and carbon dioxide which is present in the gases. Then third one is magnetic susceptibility method. Magnetic susceptibility method. So this is used to measure or estimate oxygen and nitrous oxide. We can easily measure using this following methods. So among this one, this is among the special methods, you have only this H2S detection system for your syllabus and oxygen detection system for your syllabus. So this rest all we are not going to cover this one. So CO2, H2, this CO2, this nitrous oxide, we are not going to cover. Among that one, only one chemical method and one magnetic susceptibility method is there for your syllabus. The first one will be the chemical method, H2S detection system. This is very important. If you verify the old question papers, this is many times given by this particular, many times given in your this H2S detection system is many times they have given, they are giving in the examination. So what is the principle behind this operation? So usually the reflectance of the paper tape, okay, will be changing depending on the chemical deposit on the particular paper tape. Okay, if the paper tape is containing something, a chemical deposit onto that one, depending on that one, the reflectivity, the reflectance will be lowered or upgraded. We don't know that one beforehand. So the decrease in the reflectance of a paper tape due to the reaction between the lead acetate and hydrogen sulfide by forming lead sulfide is used to determine the amount of H2S in the gas. So how it will operate first? So there will be a pulley, okay, a cylindrical pulley towards. So they will be rotating according to their axis. They will be rotating like that. So ends of this pulleys will be connected to the rubber, paper tape. Okay, usually this paper tape will be there that will be connecting this two pulleys. Whenever they are connecting like this, they will be rotating on their own axis, and due to this rotation, they will be passing this rubber, this paper tape will be passing through the gas chamber. or a gas sampling chamber, we can say. So gas which is laden with this H2S or hydrogen sulfide will be sent using some auxiliary pump into the chamber. Whenever this hydrogen sulfide containing gas is getting inside and leaving outside, so if there is some hydrogen sulfide which is present in the gas, so this tape will be usually coated with lead acetate. So this lead acetate will be having a reaction with hydrogen sulfide which is present in the surrounding gas, and therefore it will produce a brownish color lead sulfide compound. So it will be a nearly brownish or black color will be there. So due to this one, whenever it is passing to the other side of the pulley, so there will be a reflectance, decrease in the reflectance of this particular particular paper tape. So due to this decrease in the reflection will be gauged by this photoelectric tube, which is situated at the starting of the paper tape, and also in the end of the paper tape there will be two photoelectric tubes will be there. So that will be calculating or evaluating your photo reflectance, the decrease in the reflectance using some Wheatstone bridge circuit or the Calendria bridge circuit. We can easily estimate the amount of lead sulfate formation. So amount of decrease in the what we say, this reflectance of this paper tape is directly proportional to the amount of hydrogen sulfide which is present in the gas. So the reaction takes place there usually will be this one. So H2S detection system. H2S detection system. So this pulley will be there. So for example, I am drawing like this. So two pulleys will be there. They will be rotating like this. Okay, they will be rotating on their axis. So this will be connected to some paper tape like this. So they will be rotating and paper tape will be just coming like that. So before sending it to the chamber, air chamber or gas sampling chamber, we can say, there will be a sampling gas which is containing H2S there. So this is gas inlet and this is gas outlet like this. Before sending to this one, there will be an coating of lead acetate coating will be there. So lead acetate will have a formula of this CH3 C double bond O2, I think, Pb. So this is lead acetate. Whenever gas is containing H2S, so this will have a reaction with this lead acetate. So whenever it is passing like this, so using the pulley, it is passing like this. Whenever it is passing through this gas sampling, if there is a H2S, it will be forming a reaction with H2S, and therefore it will be forming you lead sulfide, PBS. This is called lead sulfide. So lead sulfide, usually it will be some brownish color or black color, we can say, and it will liberate H2. So this will be liberating CH3 2 molecules of acetic acid. So this is the reaction. Due to this reaction, the formation of lead sulfide will be there onto the paper tape. Due to this formation, a change in the color will be there, brownish or black color. Due to this, a reflectance, decrease in the reflectance will be observed there. So here, to calculate the reflectance, there will be an photo tubes will be connected. Commonly, the photo tubes will be connected to some Wheatstone or this Calendria grid circuit. Therefore, the decrease in the reflection from starting to the ending point, it will be compared, and the reading, a corresponding value of the amount of H2S present in the system is directly proportional to the decrease in the reflection, reflectance of particular tape, reflectance of particular tape. So in summary, it is nothing but whenever you are giving some sample of gas which is containing hydrogen sulfide, so it will be reacting with the lead sulfide which is present onto the paper tape. So due to this reaction between them, a lead sulfide will be formed. So this lead sulfide will be decreasing the reflectance from the starting to the ending, and therefore this reflectance value will be gauged by some photoelectric tube. So this photoelectric tube will be connected to some Wheatstone bridge circuit or some bridge circuit, and therefore it will give a change in the lowering of that particular reflectance value. Then the amount of hydrogen sulfide which is present is directly proportional to the loss of your reflectance of the tape. Therefore, in order to calculate these two reflectors, there are two photo cells will be there that will be connected to the balanced bridge circuit. So if required here, the auxiliary equipment like a pump can be, or a blower can be used here to just blow some gas sample into that particular gas chamber like this. Is that clear?
Yes, sir. Clear, sir.
Yeah. So the next topic and the last topic in this unit is oxygen analysis cell based on paramagnetic effect. So every material, so some materials will be subjected to paramagnetic effect. Okay, what are those materials? Like one of the material is the oxygen. So that will be subjected to this paramagnetic effect. So the magnetic susceptibility method of gas analysis is usually employed to measure the oxygen, which is amount of oxygen which is present in the surrounding air. Why? Because oxygen exhibits a relatively strong paramagnetic effect compared to the other gases. So nitrous oxide also NO will also exhibit the this paramagnetic effect. So oxygen exhibits the relatively very strong paramagnetic effect due to its polarity will be changed. So due to this paramagnetic effect, the polarity of this oxygen will be changed. The decrease in that polarity will be making use to measure the amount of oxygen which is present in this particular gases, whatever the gas we are allowing to flow inside the sample tube. So this is a sample tube, and next one is a measuring cell will be there, and this is a comparison cell will be there. In order to compare this polarity of this pipes, of these two filaments, so there will be two cells. One is a comparison cell, another one is a measuring cell. So oxygen meter. So this is also called as a oxygen meter, which contains usually the identical resistance wires will be there. So these two wires are very much identical with the same material of construction. We will be using in the same cells. The identical resistance materials will be used. So there the measuring cell is usually situated in some magnetic field. A magnet will be there, permanent magnet will be attached to the measuring cell. Whereas if you see here, there will be no magnetic field inside the comparison cell. Whenever the gas sample passes through this sample tube, the bottom is the sample tube. So what happens due to the aspiration? So due to the aspiration of this resistance wire, which is attached to the bulb, so it is heated bulb. Due to its aspiration, so it will have a tendency to attract the oxygen. So therefore, in both the comparison cell and measuring cell, both have a tendency to attract this oxygen into it due to the aspiration. Whenever they are attracted, if the if the oxygen, one cell is held at a magnetic field. So what happens in the magnetic field? So this whenever the oxygen is coming in close contact with the heated lamp, its polarity will becomes very strong. Its polarity will be becoming very strong, and therefore it will result in the pushing down this oxygen molecule to the sample tube. So incoming oxygen molecule will be pushed down to the sample tube. Whenever the greater the amount of oxygen is there in the sample, the greater will be the circulation of this particular oxygen in the measuring cell. Then the measuring filament is therefore will change its linear resistance, and which is directly proportional to the amount of oxygen which is present in that particular sampling cell. Then the two cells are usually there. The one is a comparison cell, another one is the measuring cell. Both are connected directly to the bridge circuit. Therefore, their resistance will be compared accordingly, and we can predict how much amount of oxygen which is there in the measuring cell, which is coming in the measuring cell. So here is one is a sample tube will be there. Inside that sample tube, using some blower or something like that, a sample which is containing oxygen will be pumped inside. Whenever it is going to the sample tube, due to the identical wires which are present in the comparison cell and measuring cell, they will be attracting the oxygen due to its heated filament or due to its aspiration. So obviously, when one cell is located in the permanent magnet, due to this magnetic susceptibility, its polarity will be very strong. Okay, this particular wire material polarity will be very strong. Due to this increased polarity, what happens? It will be pushing down all the oxygen metals which are not metal, oxygen gas which is there. So that will be attracting more amount of oxygen towards this measuring cell, and therefore due to this attraction of this oxygen towards the measuring cell, so this will have a resistance. This will change the resistance, linear resistance, and therefore there is a proportionality relationship between amount of resistance change is directly proportional to the amount of this oxygen which is present in this particular measuring cell. So that is the principal working and this construction of this particular cell. I hope it is clear.
Yes, sir. Clear, sir.
Okay, so this is the completion of unit 2. So tomorrow Jeevan is going to present this one.
Yes, sir.
Okay, mercury, I think this pH concentration measurement.
Two are there, sir. One is a glass electrode, one another is calorimeter test.
Calorimeter electrode, yeah, reference electrode. Two means same will be there.
Almost same
Measurement is
working,
one
but
only.
interior designing is different. That's it.
Yes, completely different.
One
Okay,
is plain
this
glass
component of
film. Another is mercury and mercurous chloride.
yes.
Yes, sir.
Yeah, please go through that one.
Yes, sir.
So, and next the rest of the time, what we'll do now?
Sir,